Welcome to a wave equation example. So in this example, a 40 centimeter string has both ends fixed. The string is plucked so that it has an initial displacement f of x and initial velocity g of x, where f of x is 1/4 x between 0 and 20, and 10 minus 1/4 x between 20 and 40. And g of x is just sine of x. If a equals 5, solve for u of xt. So just going through briefly, we have a 40 centimeter string, so that means our L is 40, has both ends fixed. So this is our u of 0t equals 0 equals u of lt. So we are dealing with a case, and we have a equals 5. So we are dealing with the case where we have the second partial with respect to t of u is equal to 5 squared times the second partial with respect to x of u. We have u of 0t is equal to 0 is equal to u of 40t. And then we have our u of x0 is f of x. And the first partial with respect to t of x0 is our g of x. So this is the situation that we are in. We solved this in the previous video. So in the previous video, we found that u of xt was equal to the sum from n equals 1 to infinity a sub n times cosine of a n pi over lt times sine of n pi over lx plus the sum from n equals 1 to infinity of b sub n times sine of a n pi over lt times sine of n pi over lx. Our a sub n was 2 over L times the definite interval from 0 to L of f of x times sine of n pi over L x dx. Our b sub n was 2 over a n pi times the definite interval from 0 to L of g of x times sine of n pi over lx dx. So now if we go ahead and plugging in L equals 40 and a equaling 5, we get then that our a sub n is equal to 2 over 40 times the definite interval from 0 to 40 of f of x times sine of n pi over 40x dx. Our f of x was 1/4 x from 0 to 20. So let's go ahead and split out 20. We have 1 over 20, reducing 2 over 40 to 1 over 20, times the definite interval from 0 to 20 of 1/4 x times sine of n pi over 40x dx plus 1 over 20 times the definite interval from 20 to 40 of between 20 and 40 x was 10 minus a quarter x, then times sine of n pi over 40 dx. Doing our integration by parts, we know x sine, we'll do x and sine of n pi over 40 as our, n pi over 40x as our first u and dv. And then we will do u of 10 minus a quarter x and a dv of sine n pi over 40x. I noticed I forgot to write an x in my previous integral. There we go. Differentiating our first u, we would go to 1 and then 0. Integrating that sine n pi over 40x, we would have a negative 40 over n pi cosine of n pi over 40x, followed by a negative in parentheses 40 over n pi, close parentheses, whole thing squared, sine n pi over 40x. Looking at our second integration by parts, we would be starting at 10 minus a quarter x, differentiating would go to negative 1/4 and then 0. Integrating that sine n pi over 40x, again, we would have a negative 40 over n pi times cosine n pi over 40x. Then we have a negative 40 over n pi squared sine n pi over 40x. We do the positive product on the first diagonal, negative product on the second. And we wind up therefore getting that our a sub n is equal to, we have 1/20 times a fourth for that first integral, since I didn't include the fourth. Then we have this whole thing as multiplying negative 40 over n pi x cosine n pi over 40x. And then we have a plus 40 over n pi squared sine of n pi over 40x. Let me shift this whole thing to the left so that I have room to finish the line. And then this integral is being evaluated from 0 to 20. Then to that, we are adding 1/20th times the other integral we found. So we have negative 40 over n pi times 10 minus a quarter x times cosine n pi over 40x. And then we have minus a quarter times 40 over n pi squared times sine of n pi over 40x. And this one we are evaluating from 20 to 40. So plugging in and simplifying, we are looking at a sub n is equal to 1 over 80 times, we would have a negative 40 over n pi times 20 would be a negative 800 over n pi times cosine of n pi over 2 plus 40 over n pi whole thing squared times sine of n pi over 2. So that's plugging in 20. Then we subtract off what happens when we plug in 0. So we'd have a 0 for the first one since we have cosine, or sorry, since we have an x cosine. And then we'll have another plus 40 over n pi whole thing squared times sine of 0, which of course also goes to 0. So that's the first definite integral. Then we have plus 1 over 20 times, now we're going to plug in 40. So we have a negative 40 over n pi times 10 minus 10 times cosine of n pi minus a quarter times 40 over n pi squared times sine of n pi. Then we need to subtract off what happens when we plug in 20. So we'll subtract off negative 40 over n pi times 5 times cosine of n pi over 2 minus a quarter times 40 over n pi whole thing squared times sine of n pi over 2. And that was the second integral. So again, our sine of 0 goes to 0. 0 is clearly 0. Our sine of n pi goes to 0. We still have our cosine of n pi, except 10 minus 10 goes to 0. So we are essentially just left with the parts that have the n pi over 2 involved. So we have a sub n is equal to, multiplying in that 1 over 80, we would have a negative 10 over n pi times cosine of n pi over 2. And then we would have plus 40 squared divided by 80 should be a 20 over n squared pi squared times sine of n pi over 2. Then we have plus 1 over 20 times negative negative. So that becomes plus 1 over 20 times 40 over n pi times 5 would be a plus 10 over n pi times cosine of n pi over 2. And then we have plus 1 over 20 times negative negative becomes plus, and then 1 over 20 times 1 over 4 would be 1 over 80 times 40 squared over n pi. Again, becomes 20 over n squared pi squared sine of n pi over 2. Then minus 10 over n pi cosine n pi over 2 and plus 10 over n pi cosine n pi over 2 cancel each other out. And we wind up just getting that our a sub n is 40 over n squared pi squared sine of n pi over 2. Sine n pi over 2, again, if we look at our unit circle, our even n are on the two spaces where we're on the x-axis and sine is equal to 0. So for n even, we have sine of n pi over 2 is equal to 0. For n odd, let's go ahead and set n equal to 2k minus 1. We get the sine of n pi over 2, or sine of 2k minus 1 over 2. 2k minus 1 pi over 2 is, we will have a negative 1 raised to a power. It'll either be k or k plus 1. So if we plug in k equals 1, that would be n equals 1, and we would be looking at positive, we would be looking at just pi over 2. So we'll need a positive case for k equals 1. That means we need negative 1 to the k plus 1. And so we wind up getting then that a sub n is equal to 0 for n even, and negative 1 to the k plus 1 times 40 over 2k minus 1 squared pi squared for n equal to 2k minus 1. There's our a sub n's. Now we need to find our b sub n's. B sub n, we were looking at 2 over a n pi. A was 5, so 2 over 5 n pi times the definite interval from 0 to 40 of g of x times sine of n pi over 40x dx. So we have 2 over 5n pi times the definite interval from 0 to 40 of sine of x times sine of n pi over 40x dx. We'll use the fact that sine of a times sine of b is equal to 1/2 of cosine a minus b minus cosine a plus b. So we get that b sub n is 2 over 5n pi times the definite interval from 0 to 40 of 1/2 times cosine of n pi over 40 minus 1x minus cosine n pi over 40 plus 1 x dx. This becomes 2 over 5n pi. Actually, let's go ahead and pull out that 1/2. So we have 1 over 5n pi times the integral of cosine of n pi over 40 minus 1 times x. We would have, actually, before we do that, let's rewrite these as let's rewrite them as with fractions. So we'll do definite interval from 0 to 40 of cosine of n pi minus 40 all over 40, then times x. And then we are subtracting off cosine of n pi plus 40 all over 40 times x and dx. So doing our integration, we have 1 over 5n pi times cosine of n pi minus 40 over 40x will go to 40 over n pi minus 40 sine of n pi minus 40 over 40x. And then we'll have minus 40 over n pi plus 40 sine of n pi plus 40 over 40x. And then we are evaluating from 0 to 40. So this becomes 1 over 5n pi times plugging in 40. We have a 40 over n pi minus 40 times sine of n pi minus 40 minus 40 over n pi minus 40 times sine of n pi plus 40. Sorry, this should have been minus 40 over n pi plus 40 times sine of n pi plus 40. And then we subtract from here what we get if we plug in 0. Plugging in 0, we'll have a 40 over n pi minus 40 sine of 0 minus 40 over n pi plus 40 sine of 0. Both those sine zeros just go to 0. So we just have our sine of n pi minus 40 and sine of n pi plus 40 terms to work with. If we wanted to simplify further, we can. So we have we'll use the fact that sine of A minus B is just sine A cosine B minus sine B cosine A. Let me actually check that I have that subtraction. All right, that is correct. I wanted to make sure I had the order correct for the subtraction fact. So sine of A minus B is sine A cosine B minus sine B cosine A. We also have that sine of A plus B is sine of A cosine B plus sine of B cosine A. So we get that our B sub n has 1 over 5n pi times, we had a 40 over n pi minus 40 times sine of n pi minus 40. So this would be times sine of n pi times cosine of 40 minus sine of 40 times cosine of n pi. Then from that, we were subtracting off 40 over n pi plus 40. Times sine of n pi plus 40. So this would be sine of n pi cosine of 40 plus sine of 40 cosine n pi. So our sine of n pi's go to 0. Our cosine of n pi goes to negative 1 to the n. Oops. And so we wind up with our B sub n is equal to 1 over 5n pi times, we have a negative 1 to the n times negative sine 40 would be a negative 1 to the n plus 1 times, then we have a 40 sine 40 over n pi minus 40. Then we have a minus 40 over n pi plus 40 times a negative 1 to the n. So we have a plus negative 1 to the n plus 1 times 40 sine of 40 over n pi plus 40. And this becomes -1 to the n plus 1 times sine of 40 all over 5n pi times 40 over n pi minus 40 plus 40 over n pi plus 40. I'm going to stop here. You could stop at any point prior to this as well. As you can see, we have our constants for both a sub n and b sub n. And so I'm just going to box our formulas for a sub n and b sub n. And then our final formula is that u of xt is equal to the sum from n equals 1 to infinity of a sub n times cosine of a, so 5n pi over L, so over 40 t sine n pi over 40x. And then plus the sum from n equals 1 to infinity b sub n of sine of 5n pi over 40t times sine of n pi over 40x. So this is our sort of the three things I boxed make up our complete solution. You could go in and actually substitute in our a sub n's as we have, or we can leave it in this format. I want to verify in my original formula that I did indeed write t. Yes, I did. Okay, so this is our lengthy solution for solving for the coefficients for our formula, or for our function. We already knew the formula and fit. It was just a matter of solving for the coefficients. For exams coming up in this class, I will provide an integration table, so you do not have to go through all the annoying integration by parts. I will provide integration tables for you.